Good. Do we have any questions for the previous seminar, assignment 3, or any of the previous one? Any problems? How was the effort for it? Too much? 1 hour, 2 hours, 3 hours, 10 hours?
Have you done anything?
I need to check, but the debugging took a lot of time.
Yeah, the debugging one was number 2. Also, did you look at the last assignment? At the block diagram one?
Yeah, I did it yesterday.
Was it okay?
It was better, yeah.
Okay. Yeah. It really depends always. The block diagram, if you do a mistake, can be nasty because at this point I would just start drawing it up again because finding that one signal you did wrong can take a while. Good. But if there's nothing now, I can show you briefly, or like overview of assignment 4, which we're gonna focus on simulation and verification as in the class. Can I make this bigger? Yes, I can, certainly, somehow. There we go. So, has 3 tasks, of which one is optional because it would be really good for you to figure it out. But also I see here a potentially more significant effort to kind of think through the logic. On the other hand, it might be also quite easy, depending how familiar you are with VHDL. But it's going to be definitely a good exercise. I wanted to give some incentive that it's being done. The overall assignment will go not into code coverage as in the lecture. It will go more into the setup, the configuration, and then some self-testing. So some asserts to get some responses. All of that is done in VHDL because I do not want to introduce another language and make it more complex. Generally, many people prefer System Verilog for simulation, and then you just do mixed simulation. Not every software can do it, or according to the licensing, but it might be easier to write certain things. So essentially, the assignment is being put into 2 parts. One is your simulation setup, and the other part is then actually building or extending the self-testing of the simulation itself. I also created a tickle file, which you can just do simply also from your project. I will show that in a second how that's being done. And that when you execute it, it will load up the entire project from scratch. You do not have to do a manual design entry and all these kind of things. You have the files, you run it, and the entire Vivado project is there. And then you just gotta click on the simulation button, which is of course quite convenient, especially if you, let's say, are in a collaborative project and people change it and then you update just the tickle file, you run it from scratch and that's fine. If you have something to change on the architecture. And the rest of the code you would anyways just do with Git, with VHDL, it's fine. But configuration files might change. The first task is the task on simulation configuration. Essentially, we have not yet looked at any configuration of the simulation unless you have done it yourself. So this is the assignment where I expect you to start setting up your simulation properly, save the configuration file to not have to go repeatedly through manually aligning all the signals, coloring them in and so on. I will show you in a second how this is being done and overall, and then you can explore. Also part of the assignment is to explore options which are convenient for you. And then basically what is to be delivered out of this is, of course, like the report and potentially screenshots, but also the saved configuration file from Vivado, which then you can use in the future for other stuff. Consider it should be like simulation run. Otherwise, you have to how long you want to run it, and which format you want to run it, which signals you want to log, these kind of things, and then the other part configure the waveform automatically, so that you have the signals in the right order and the right color with the radix, with the values shown in a way that they're most useful to you. We will go through the entire workflow essentially after I go through the tasks here. The other part is you will find in the code in the test bench 2 to-dos. One to-do is for the coding task, one is for the bonus task. The first task is about the self-testing. So essentially, we want to check if our UART response is the one which we expect. And I've given you an example for this, and basically you would extend it to the rest of the sent data, which you can of course just copy paste, but you also can in a certain way and adapt it as needed if you understand the code. Code understanding is still required for the copy pasting, and then or you can of course advance it and make it even more self-testing, maybe more flexible. I can give you some options what might be possible for yourself. And the last task, the bonus task, is essentially as we have an arbiter, like a data router. Right now in the self-testing it's not included that the signal is being checked according to the configuration of the router. So the task would be according to the configuration signals, you would check the according ports for the response at the right time, which is not implemented at all right now, which would be a bonus task for you guys to explore and make a bit of a better test bench, which will be in the long term very useful for you. Maybe not here in this course so much anymore, but it's a coding skill. It's also VHDL, so you just code there a bit more. So basically suggest to get these points, it's going to be like half points roughly. Suggest an approach for the self-testing. If the approach is viable, but you did not manage to implement this, you will get half a point, and the other half point is for then the implementation of it. Concept in VHDL is always the most important part to actually figure out what can be done in which way and understanding what could be done. Of course, suggesting an approach is half a point, but you cannot verify it unless you have actually implemented it. So I will try to assess that accordingly, that it would make sense. Of course, if you have an assignment and think I've misunderstood the approach, we can talk about it and then you can get a half point later. So, yes. Good. Any questions to the tasks themselves? We will upload them. I don't know, Stan might upload them now or in between. I saw a typo somewhere, but we'll upload it afterwards. That's fine. If there's no questions on this particularly right now, we'll go through Vivado. So basically, what you can do here, and I love automatizing workflows, especially in VHDL design. You essentially just need to go here in the command line. You need to go to your repository, where we, of course, this is just we have here particle FPGA design, and I have the folder where I've copied my stuff into. That's basically the folder you will have gotten as a zip. Oops, I shouldn't select the file for the path for the folder. And then you just type source, and then you make assignment tickle. And that basically will run and create the entire project from scratch without any previous log, just with your code for like hardware description, constraints, and a wrapper. So for here, essentially you just have, in the original file you have only, in the zip you have a source folder with constraint simulation, source and utilities. And then you have in the generator, you have another router wrapper, which might be useful. And the tickle script is automatically generated by Vivado. It's like, I would not recommend to write this yourself unless you want to write 900 lines. Of course, you can adapt this when you understand it at some point, but I adapted, for example, the paths, so I do not, because it will reference to the previous project where you come from. So it's essentially meant that you can always create a project from a base file repository. So I needed to adapt some things. So this essentially, when this is being done, yes, when it's finished, we can, just to show you how it's being done, you write go on project as a file project, write tickle, and then you can make a block design using tickle. So everything out of this will be basically exported as you need it, and then you can create a new project. That's a function which I used to do this. Oops, I do not want to create another one. And here you can look through the log here if there's anything critical in here. There's one important part is that you want to check for warnings or any errors where anything failed. Maybe there was a wrong path or something like this. If you have such issues, would need to look into it. From essentially the source files should be on the same level as the tickle script. Let's put it like this. if this works, this has worked for me in different folders. If not, then we would need to explore. Maybe you can figure it out yourself. You would learn a lot from this, but also I can see that it might be overwhelming. The other part is that you will have to have set up your IP catalog correctly. So you want to have actually the RX and the TX from the previous assignment included as IP cores in your project. Otherwise, this project will not find your IP cores, logically speaking, of course. If you do not have them integrated in your current configuration, which would give you here an error, like here the Git repos with the IPs, then you would need to add that path in, as previously said, also to your IPs repository, and here the folder. That's an overall Vivado setting, which might be missing. If you have done this, then it should not be an issue to find the RX and TX folders, IP cores. Good. The design is essentially the previous assignment filled in extensively with some functionalities. The test bench has been adapted because I found some issues in the data interpretation on the test bench side, but that this did not affect your previous assignment. So what I can actually do already from start here, I can just run the simulation, behavioral simulation. We do not need any other. If you're interested, of course, to see how long or how it affects the design, you're always welcome to run synthesis implementation. We always had this in previous project and previous assignments, so you always feel free to do this. In this case, I have not tested it, but also, again, it's the same as the previous assignment, which has essentially just the simulation here changed or extended. In the assignment after this one, potentially we will look into more implementation and synthesis tasks to look into how much resources things take. As you may notice, it is the default setup now. I will make this a bit bigger so you can see this better, and I can make this smaller as well. It will always, what is very annoying, will always run it only for a default length of like one microsecond or something like this. And then you here for me is already from the past, 500 microseconds selected. I can scale this again, and then I will get here a UART and we'll get a response on the RX, on the TX one, which is then on my side receiving one, and here are according other routings. If you want to change this, of course, you can always go into the test bench, change these kind of things. They are not fully automatized yet. I did not have the overall time to do this. Of course, again, if you want to have a proper design and test bench and you will make a more complex data stream, you will have to go away eventually from writing those separate lines for each configuration, because it will just get very, very long, and you might make human error when you just have a typo in there. You want to have it as simple as possible in a simple configuration. So the simulation, for example, works here. I also get here already expected and received data. It's kind of nice for you to see if there's any other error. For example, from the checking, from the comparison, expected data to received data, we see here D5 and D5. That's wonderful. And also in my test bench, I have implemented an assert as an assert / a check with a report. There's two ways to check the correctness of your signal. There's first making an if-else, of course, and then writing the report, and then adding a severity. And the other one is to make an assert and comparing the assert, which does pretty much the same. But I'm not aware that there's an if-else possible, so you would need to write each state separately, and maybe that's a bit annoying for you. Yes, those are the two options, and basically when we will go into the tickle console, TCL, you will see besides certain durations and so on, we will see here that we got the correct data in SRX1 serial, so in the data which we have received. And also in this case, because all of the test correct flag has always been set to true, will be correct, will say that all data correctly routed. I see here, for example, that potentially when you do another test that you might overwrite a false consider this when you add more test scenarios. Exactly. So this would be already one thing. For explanation of the code, briefly, there are some comments in here. For example, you wait here just for the signal to arrive. RX1 signal, you will wait for the middle of your UART bout, so you are the most stable signal for analysis, and then you will just run through the 9 bits, and for receiving data, start, then the data, and then it's anyway stop. But this, which is relevant for your receiving. For the sending, there's the previous functionality, which I have extended a bit and corrected the previous procedure to sending the data. This should be also correct now. And this is being used repeatedly here. Exactly, so this was then the coding stuff. For configuration, there's 2 things which will be useful for you. First of all, the overall simulation settings, which you just find under settings, simulation, and then of course here simulation, and then you might want to add log all signals. I will show it briefly before this something quickly. This signal, actually is complete. Wait, if we go in here, if I load this here, I have no signals logged. This might be quite annoying. I've shown this before. I would need to rerun the simulation now. What I also can do is I can change my simulation settings to logging all the signals and also to run for a while. And then there's other settings which you can go through to let it run for a certain duration. For example, 1,000 nanoseconds is quite annoying. Let's let it run for 500 microseconds. And if I apply this, I will have to restart my simulation. Oops, I do not want to save it. So now it closes everything, and I will have to restart my simulation here from scratch. Makes it a bit easier. So these settings I can change, and then I will have all the log of all the signals, for example, now and there. This is something for you to figure out how long you want to run it, and if you find a way to actually exit the simulation or similar. You can always let the simulation crash, for example, and when you have an error, so you will let it crash at the error exactly. Now you can see we have 500 microseconds, and then this will automatically run my full simulation. Well, almost full here. I gave it the wrong time, but essentially let it run until the end. The other part is, so this is the configuration, which the settings in Vivado itself. Of course, they can also be scriptified with a ticker script. Whatever you prefer, you can also do that. There's many commands which actually lets you just put certain settings into a ticker script automatically, and then you adapt that so you do not have to change anything or write anything from scratch, really. The other part is using here these save waveform configuration. This is what you see right now in the waveform. You can save this. According to the project, that's also the file which I expect you to submit. And that file basically you can save wherever you want to. So for example, to simulation, logically. Simulation 1, and behavioral, for example. And I can save it wherever I want, can I? Yeah, so that is, wherever. I will put it here to simulation 1 though. Because maybe my simulation 2, my other setup might want another setting. Then I can save this. And this is now, wow, okay, nothing changed, and I will just, because I did the default one. But what I can do now is, for example, what I did before when I was debugging the assignment, I changed the radix to binary just to see if anything is flipped very quickly, or see what bit am I exactly missing, because I do like to think as little as possible. I just compare values to each other, and actually I can make all these to radix binary, and then I will see immediately which ones are correct here. I also could add, for example, to scope, I don't know, I want to see if actually my UART received the right data. I will add those signals to it. And then I will make them, just because I want to have them gone. Here the clock is unnecessary, I have the clock above. I'm just making something up now. I want to have, for example, received data. to here. Those are my ground truth, whatever values, whatever you want to call them. I will make them, I don't know, magenta, so they're pink, or magenta, pink. And then you can save the configuration again. It will just override it. Hopefully this has worked now. And then I can actually close my simulation. And then when I run the next simulation, it should hopefully load according to what I just have specified. Some faster with power, with external power. There we are. And this will basically show me, of course I can also save the layout and all these kind of things, like how Vivado works, it's more than this. But you see here, that will basically load all of these things up. Come up with something which is logical for you, with some reasoning, some short argumentation, so that makes sense. And a screenshot of this, and then we can see in the report simply that you have thought about the simulation setup. And there's not one truth. Maybe if you make it easy, you figure out how to do these things. Then you make the debugging of the solution of task 2, and for that you will use the assignment, the configuration, and you will just screenshot that configuration and load that, and you say that's the configuration I used for solving task number 2, for example, and that would be the most efficient, for example, to do this task. Whoops, Vivado's being buggy again, but I think that's it. So you know how to change the settings, how to add a configuration, what you can change. You can also align them. All of this will be included. And the last part is then adding here, making more than just one test number 1. And then there's here at self-checking for the rest of the sent data, so the 2 other bytes. And then here is the correct routing is the other to do. So that would be then the coding part. I think that's it. Do you have any questions? I hope this one is a bit also nicer than the debugging one. You have to code here from scratch, but on the other hand, you have to code from scratch. So it's always a difficult part to find the right paths, especially when you do not know the code yet.